Hello, my name is Melnychenko, and today my question is from the Grade 12 Advanced Functions Nelson textbook, Chapter 2, Review. And my question is, page 117, number 11F. In the textbook, you are shown this, and the question asks, a maximum or a minimum is given for each of the following functions. Select a strategy and verify whether the point given is a maximum or minimum. The equation that we get is m of x equals 1 over 20 in brackets x cubed plus 2x squared minus 15x, and we have to determine if negative 3 9 over 5 is a maximum or a minimum. Step 1. Determine if there is a turning point at x equals negative 3 using IROC. Step 2. Factor and simplify the equation that we were given. Step 3 is find all the essentials needed to graph this function. This includes zeros, degree, leading coefficient, and y-intercept. Step 4. Find points to graph this function. Step 5. Graph. And step 6. Determine if negative 3 9 over 5 is a maximum or if it is a minimum. Alright, now we're going to start with step 1, which is using IROC. Now you might ask yourself, what is IROC? IROC is instantaneous rate of change. The way you find your IROC is quite simple. You find the slope of your tangent line. Time for calculations. Since we're trying to find the IROC at negative 3, what you want to do is subtract 0.001 from negative 3 and add 0.001 to negative 3. What you end up getting is negative 2.999 and negative 3.001. Now what you want to do is plug in these x values into your equation. As you can see, this is our equation, and we're going to have to sub in our x value into this equation. Now you're going to want to substitute negative 2.99 into these four spots. After punching this into my calculator, as you can see, I got a value of 1.799. Now I'm going to do the same thing with my other x value, which is negative 3.001. After punching this into my calculator, as you can see, I got a value of 1.799. This is a chart showing my x values with my corresponding y values. The base equation to find the slope of our IROC is m equals y2 minus y1 over x2 minus x1. Now we're going to plug in our values for x and y, so it's going to look like 1.799 minus 1.799 all over, in brackets, negative 3.001 minus, in brackets, negative 2.999. After putting this in my calculator, I found that it equaled 0 over negative 0.002. And as we know, 0 divided by anything gives us a value of 0. Here you can see what our tangent line looks like. And as we have previously determined, the slope of our tangent is equal to 0. This means that there is a turning point at x equal to negative 3. Step 2, which is factor and simplify the equation we were given. First, we're going to take out the x, so we're going to get 1 over 20x, and then in brackets x squared plus 2x minus 15. Now we have a simple trinomial. The way we're going to solve this simple trinomial is to see what multiplies to negative 15 and adds it to. I figured out that negative 3 and 5 work perfectly. So now we have x squared minus 3x plus 5x minus 15. Now we're going to factor by grouping. We're going to factor out x out of the first bracket and 5 out of the second bracket. This leaves us with x plus 5 and x minus 3. Now, when we put this into our regular equation, we're going to get 1 over 20 x plus 5, and x minus 3. Step 3. Find all the essentials to graph. First, we're going to find the zeros, also known as x-intercepts. The way to do this is to isolate for x and get your value. As you can see, our zeros are 0, negative 5, and 3. Next, we're going to find the degree of the function. The degree will help us find out what our function will look like. For example, the even function is going to look like a parabola. On the other hand, odd functions will look more like a cubic function. Even functions can have a degree of any even number, like 2, 4, 6, 8, etc. Odd functions will have odd numbers like 1, 3, 5, and etc. Now to show you how to find the degree of your function. The way that you can find your degree is by looking at your variables and looking at the exponents. As you can see, all of these have an exponent of 1. Now all you have to do is add the exponents, so it's 1 plus 1 plus 1, which equals 3. Therefore, the degree of your function is odd. Now we'll have to find the leading coefficient. As you can see, this is an even function with a positive leading coefficient. This is also an even function but with a negative leading coefficient. Right here is an odd function with a positive leading coefficient, and here is another odd function with a negative leading coefficient. The way you determine if your leading coefficient is positive or negative is by looking at your a value and seeing if it is positive or negative. As we can see, 1 over 20 is positive, therefore the leading coefficient is positive. Next, we're going to find the y-intercept. The way to do this is plug in 0 for x. After putting this into my calculator, I found out that my y-intercept is at 0. So after doing all this work, we determined that the zeros are at x equal to 0, 3, and negative 5. We also determined that the degree is 3, which means that it's an odd function. The leading coefficient is a positive, and the y-intercept is at 0. By looking at the leading coefficient and the degree, we can determine that our graph is going to look like an odd function with positive end behaviors. Step 4. Find points to graph. The x values I have chosen is negative 4, negative 2, negative 1, 0, 1, and 2. And what you want to do is plug these x values into your equation. At x equal to negative 4, you get 1.4. Negative 2 had 1.5, negative 1 had 0.8, 0 had a value of 0, 1 had negative 0.06, and 2 had negative 0.07. Step 5. Graph. As we already determined, these are our x and y values for our graph. We also determined the zeros at 0, 3, and negative 5. Also, we determined the intercept at 0 and our turning point at negative 3 and 9 over 5. Now we're going to jot down our points to see what graph we get. And plug in our zeros at 0, 3, and negative 5. Looking at the degree and the leading coefficient, we know that our graph will look somewhat like this. Since we know our leading coefficient is positive, we know our end behaviors will look like this. Right now I'm pointing out the point negative 3, 9 over 5. Step 6. Determine if negative 3, 9 over 5 is a maximum or a minimum. When looking at the graph, you can see that negative 3, 9 over 5 is the highest turning point, making it the maximum. Therefore, on the graph, m of x equals 1 over 20 x cubed plus x squared minus 15x. Negative 3, 9 over 5 is a maximum. This strategy helps a company know their financial trend and for them to know their highest and lowest points of sale, so like the maximum and the minimum. This can help a small business owner, a big business owner, and even a stockbroker. Thanks for watching. I hope I increased your knowledge on strategies you can use to find the maximum or minimum of a function.